Good day and welcome everyone to Power Bytes. I am your host, Lou Signorelli, and Power Bytes is your destination podcast for power generation conversation. As always, please know how much we appreciate you, our listeners. We hope you find our topics both helpful and interesting. There are several ways for you to get in touch with the show. You can send us an email at powerbytes, that's power, B-Y-T-E-S, at cat.com. Visit us at Cat Electric Power on Facebook or LinkedIn. But please, if you enjoy your time with us today, please remember to subscribe to our podcast, leave us feedback. That all helps us a great deal. Okay, do you know what a generator transient is? Do you know how your generator will respond to transients, large and small? Well, today, joining me via the Cat Electric Power Hotline is one of our resident application experts, Mr. Bryan Snyder. Bryan, for our returning listeners, you'll recognize him for his work on overcurrent protection and a few other podcasts. He's becoming quite famous. For our new listeners, Bryan has 20 years of experience with Caterpillar and a career of focusing on integrated systems and gensets. Welcome, Bryan, and thanks for joining us today.
Thank you, Lou. It's great to be back with you.
Bryan, can you help us define what a transient is on a genset?
Yeah, whenever there's a sudden change in the load supported by the genset, the frequency or the voltage of the generator is likely to be impacted for a temporary period. This change from steady state operation is considered a transient. If the load on the generator increases, the speed of the generator slows down. This impacts the frequency and the voltage of the generator, causing them to dip. If the load decreases suddenly, the speed of the generator is likely to increase. This will cause the generator to overshoot. The measure of how large the dip or the overshoot and the time it takes for the generator to return to its steady state operation, this is what's typically considered the transient response of the generator.
So, Bryan, what causes the load on the generator to change so suddenly?
So there's several reasons for a sudden change in loads. Things like large motors or other loads can cause sudden changes when they're turned on. If there are several automatic transfer switches in a facility, sometimes when they're changing to transfer the loads onto the generator or to remove the loads, you'll see that as a transient as well. And there are also large sudden demands like things from transformers. As they're becoming connected to the system, they'll become energized, and that will cause an inrush for the generator as well. So the size of the load and normally the nature of the load will determine the size of the generator's transient response.
So is it possible, Bryan, for you to explain what is happening in the engine when a transient occurs?
Sure. This is often done better with visuals, but if you can imagine, an engine is operating with a specific amount of fuel and air supplied to the cylinder to produce the necessary power to support the steady state load. This is called the brake mean effective pressure, the BMEP. When a large load is added to the generator, the power being produced under the steady state operation can no longer support the demand from the load, and the speed begins to slow. To increase the BMEP, the engine applies more fuel. As the fuel increases, the engine BMEP will rise. During this time, most of the modern engines will also use turbochargers to increase the air into the engine as well. And when the engine BMEP meets the requirement of the load, the speed stops dropping and then begins to start to rise. So the engine will continue to increase fuel and air until it reaches its maximum fuel setting. During this period, the speed will return back to the steady state settings, and the fuel will then reduce back to a steady state operation with a new BMEP and a new power level to support that new level of load.
Thanks, Bryan. I think I understand that a lot better now. So I understand there are some industry standards to define how transient responses should be measured. I did a little legwork and found ISO 8528. Can you fill us in on this standard and its application?
Yes. So ISO 8528-5 is the most common standard for transient response. This standard has two primary concepts that are critical to evaluation of generator transient performance. The first is that the load steps applied to the generator should be based on the BMEP of the generator. As the standard states, a higher BMEP usually makes loading in several steps necessary. What this means is that you may have two generators with the exact same power rating, but because one has a higher BMEP rating, it might take more steps per the standard to get to the full power. This often is overlooked or misunderstood in specifications when customers request generators meet a specific performance category. And then the performance category, that's the second part of the standard. There are 4 basic categories. So a G1, which typically is acceptable for general purpose loads like lighting. Then G2, which is more common for loads like pumps or motors. G3 is most common for things like telecommunications equipments and is often the one that's referenced most in standards. And then finally, there's G4, which is most common for high-sensitive applications like data centers or things of that nature. For G1 to G3, there are specific values allowable for everything from steady state operation to the allowable dip and the allowable recovery times. For the G4, it is an agreement between the manufacturer and the customer on what the performance should be. It should be noted that if you're using any of these rating categories, the load steps associated with those performances should be based on the load steps that we talked about previously. We'll often see specs that require the product to meet a G3 requirement, but then the customer may question why the product isn't meeting the performance at a 0 to 50% load step, for example. It's the intention of the standard to really create a level playing field for evaluating performance of different generators. If the customer is looking for a specific performance to meet their application or their load steps, it would be recommended that they specify exactly the performance that they would like rather than simply referencing some standards.
Bryan, that is so interesting. I appreciate you taking us through that. Does Caterpillar have any tools to help users calculate or predict the transient response?
Absolutely. If a customer has a specific load that they're concerned about, what we would typically recommend is to use our SpecSizer software. I know you've spoken about that in other podcasts, but if they go to SpecSizer, one word, .cat.com, so it's specsizer.cat.com, they can add the loads and specify the amount of acceptable transient. This can help the customer to select the right generator for the application. Some customers may only have 500 kW of load, but because of the transient response they need, the system may recommend a 750 kW generator set. SpecSizer is very helpful in making sure that you get the product that you need to support your application rather than getting a product to the site and finding out you have an issue.
Thanks, Bryan. There are definitely more podcasts our users can listen to for more details on SpecSizer and a variety of topics. And you can get all of those wherever you listen to your favorite podcasts. Are there other tools that we have for users if they are still having some difficulty, though?
Yes. So I would recommend that the customers that have a really complex application, that they work closely with their local dealer. The Caterpillar dealers and Caterpillar have resources that can help with making adjustments and also evaluating SpecSizer files to be able to determine where the best application of that product might be. There are also some internal tools that we have for transient analysis that if we find that the application really needs that complex evaluation, we can take that on and look at that in more detail. We also may be able to help a customer that's looking at other technologies. So we may have energy storage systems that Caterpillar has available that can help with pairing that with a generator set to provide improved transient capabilities for specific applications. And then we can talk about the other benefits that you get out of an energy storage application as well.
That's fantastic. Bryan, this has been some really great information. Are there any last recommendations you can provide for users that are evaluating their transient responses?
Yeah, there are some general items that we would normally look at and recommend for applications with a particular focus on transient response capability. So first thing, we would look at an externally sourced excitation system. What this means is that we're looking for a system that is receiving power from an external source to support their excitation. So this would be something like a permanent magnet or an internally excited generator from Caterpillar. Having these external sources for excitation energy allows the generator's voltage to recover faster during a transient. Also, we would recommend a lower subtransient reactance on the generator. This allows the generator, again, to respond faster to loads like motors or transformer inrush. Finally, if you already have a generator on site that you need to improve the transient response, there are some changes that can be made to the voltage regulator that may improve the response. We can't get into a lot of that details here, but adjusting the volts per hertz settings or the loop gains, and if you're working with a Caterpillar generator, I would recommend looking at the transient load relief function that's part of the EMCP controls. You can get more details on all of these items from your local dealer.
Well, there you have it, folks. I'd like to thank Bryan Snyder for sharing his expertise with us today, and thank you to our listeners. If you'd like more detailed and perhaps site-specific discussions, please contact your local dealer to set that up. If you'd like to experience CAT's industry-leading tools such as SpecSizer, please go to SpecSizer, all one word, spec, SIZER.cat.com, or consult your local dealer. If you'd like to suggest other topics for the program or have some feedback to share, please write us here at powerbytes@cat.com or visit Cat Electric Power on Facebook or LinkedIn. Please remember to subscribe to our podcast wherever you listen to your favorite podcast. Till next time, thanks for listening to Power Bytes and have a great rest of your day.